Hello, welcome back. We are going to start chapter 11 today, which is all about introducing geometry. So section 1 of chapter 11 is just basic notation. So we're going to learn about undefined and defined terms of geometry, basic geometric shapes, attributes, properties, and of those basic geometric shapes, and then names, classifications, and measuring angles. So there are some terms in geometry that are not really well defined. So points, lines, the center line of a road, plane alpha, so a plane is like a flat surface, a single point C, a line M, plane ABC, or just plane Y. So let's dig into a few of these terms. So a line has no thickness and it extends forever in two directions. If you are given 2 points, then there is one and only one line that will connect those points. And if P and Q are any 2 points, then we can create a number line on line PQ so that there's a one-to-one correspondence between the points on the line and the real numbers. So those are lines. This last point sounds a little bit confusing, but essentially what it is saying is that the number of points on a line is the same as the number of real numbers, which we often call uncountably many. So linear notions, we might have something called a collinear point. So in this figure we have line L. It contains 3 points, A, B, and C. A, B, and C are all on the same line L. So we say that they are all collinear. So linear to each other, all on the same line. But points A, B, and D are not collinear because there is no line that could go through all 3 of those points. Point B is between points A and C on line L, but point D is not between points A and C. So that's one of the reasons that they are not collinear. So in addition to lines, we can also define what a line segment is. So a line segment or closed segment is just a subset of a line. So it takes 2 points and it's the segment of the line that is between those 2 points. So in a way it kind of truncates our line to make it just a segment. We might also talk about being half open or half closed. So if a line is half open, then that means that, or half closed, it's like half full or half empty. If it's half open or half closed, then that means that one of the 2 points is what we call open, meaning that point is not included in the segment. We have all the other points between A and B except for A. And we could also have a completely open segment where it's all of the points in between A and B, but not including A and B. We could also talk about rays. Rays are lines that, or it's this portion of a line that has an endpoint A and goes through a point B. So that would be ray AB. So we have just one point and a line extending forever in the infinite direction. 2 rays are opposite rays if they have the same endpoint and are on the same line, and if we put them together, their union is the line. So if you think about this second picture, we have 2 opposite rays. BA is one ray, and BC is the other opposite ray, because if we put them together, then we will see it gives us the entire line. We could also talk about a half line. So a half line is a ray that we've taken the end point off of and made it an open point. Excuse me. So a ray will separate a line or a point will separate the line into three parts, which is two half lines and the point itself. So if we look at our picture up here, we have a point B that splits this line into two half lines, BA and BC, and the point itself, B. We could think about the point B being kind of by itself here. All right, so if we start talking about planes and planar notions, we could talk about points or lines being coplanar. So in this image over here, points D, E, and G are all coplanar because they all can fit on the same plane. But points D, E, F, and G are not coplanar because the point F does not fall on the same plane with the other 3 points. There's no single plane that we could create or imagine that would contain all 4 of those points. We could also say that lines are coplanar. So we can see that DE, DF, and FE are all on the same plane. You can kind of think about this triangle here created by DEF and imagine the plane that goes along that triangle formed in our picture. So we can see that those 3 lines are coplanar. We also have lines D and DE and EG coplanar. So DE and EG are coplanar lines. DE and EG are intersecting lines because they intersect at the point E. So these are all things that we can say about lines on a plane. We can also talk about lines being skew to one another. So in this picture, lines GF and DE, so GF and DE are skew lines. They will never intersect, and there's not a plane that will contain them. Even though in this picture, it looks like they have an intersection point here. Let me highlight it. They're not actually intersecting in the 3 dimensions. So that is not a point of intersection just because it looks like it on the paper. So these are skew lines. We can also talk about concurrent lines. Lines DE, EG, and EF are concurrent lines because they all intersect at the same point. So we can say DE, EG, and EF. These are concurrent lines because they intersect at a single point E. We can also say that 2 lines are parallel. That means that they have no points in common. They will never